Hello and welcome back. This is your second assignment for Module 1. The point of this tutorial is to further delve into the relationship between Rhino and Grasshopper by referencing geometry from one environment into the other. Start by downloading the 4 chair reference images. You will find them in the File section of Canvas under Content for Module 1. Now, these are famous chairs from the history of modern design. The Eames Aluminum Group from 1958, the Saarinen Tulip Chair from 1953, the Panton Chair from 1960, and the Rietveld Zigzag from 1932. Each one has a very different profile, from the angular zigzag to the continuous S-curve of the Panton, which is going to make for interesting surface creation results. You're going to import them into Rhino, scale them to real-world dimensions, trace the profiles with curves, and then reference those curves into Grasshopper to create lofted surfaces. I will ask you to produce 2 different loft variations and bake both into Rhino on clearly labeled layers, and that will be your submission. Now let's go. Small objects, centimeters. And we will begin by going to our top view and we will create a layer. So go ahead and double click on one of the layers and we're going to call this reference this. And we're going to go to our command line and type picture. And that will take us to our browser, and let's go ahead and import these one by one. So I'll start with number 1, Eames, and I will reference the origin, so I can just type 0, enter. And for now, we can just kind of extend them. We need to rescale these. Then I will be scaling these all together. So let's go ahead and import the second one, picture, enter, and import the second one. For now, I'm going to just click on one of the corners and just make sure that your end snap is on, and I will be just referencing them one after another. So these are already recropped before sharing with you. So then this way it would be easier to reproduce them. So I will be sorting them one by one. So 1, 2, 3, 4. The order doesn't really matter. It's just for us to, just process them one by one. I will be working with them in this order, right? And again, this is just for us to keep track. So 1, 2, 3, 4, and all of them should be on this reference images layer. So I do need to scale these one by one, and we'll try our best to scale them as accurately as possible. So first thing we're going to do, we're going to create a line and we're going to assume that that's our ground plane. And as you could see that the ground plane is different for each of these. So let's go ahead and I'm going to double click on this and I'm going to call this our guides. And under guides, I'll make a sublayer and let's call this ground. And you can duck the ground layer under guides and make that an active layer. So let's go ahead and create a line, and we're going to type line enter. I will use a 0 as the origin, and I want that to be a straight line, so I can turn on my orbit and just snap anywhere you like. In this case, it's not very critical. We're just trying our best to align things. And then just select them one by one and move them in a way that you feel that it's kind of referencing that. So we're not going to be, we're going to try to be as accurate as possible, but I think it's okay if it's slightly off. So just select each of these and try to align with the ground plane. You could zoom in and out, but I'm going to use kind of the center of the line to the best of my ability. So there it is. And then the last one. Okay. So then we have this scale, which is going to ultimately allow us to scale things. And since these are relative, you could see that this 18.5 is a common line that we see throughout. So technically, because they're the right size, they should be comparative. So I'm going to then draw another line, and I will use this as a guide. I'm going to create another sublayer here, and I'll call this top of the seat. And again, these are guides, so we can change this, and I'll use my command line to enter line, and I will reference that. And again, I have my ortho on, or you can use, you can hold your shift, and there it is. So that's basically the top of the seat. And as you could see, it's almost to the right scale, but I think we need to adjust these, right? So the next step for me is to make sure that actually this line is 18.5, and then I'll just begin scaling these one by one. So I am going to first drop that line down. So I'll draw another line, and I'm gonna just remain in that layer. And I will make sure that my perpendicular snap is on. I will click here, and then this way I should be able to click here. So I'm not exactly sure what that distance is, but I could give it a try and run a distance command. Then I will measure this, and you'll see that that's actually quite off, right? So that's 13.156. So and that's completely fine, because what I know is that in this drawing, this should be 18.5, although my measurement is completely off. So I'll do this one by one. So basically this needs to now read as 18.5. So I'm going to select the image. I'm going to hold shift, and then select this curve. And I'm going to select the second curve, right? And we're going to scale this accordingly. So let's go ahead and type scale, enter. We're going to press this end point, and says scale factor or first reference point. I'm going to snap to the second point, and you'll see that this way my image is scaling up and down. And what I need to do is either I need to have already drawn that 18.5, or I can type that number. So I can type that actually that needs to be, since I'm in centimeters, that needs to be 47 centimeters, right? So enter. So now that should be the accurate size. So that's the first one that we are fixing. So same thing with this. So that should be 47. So I can either continue by drawing a line, or if you're certain kind of about the positioning, because I know that that's 47, so I can just select this drawing, and I can type scale, enter, and try to zoom in. Try your best to turn on near. This is one of the few times when near is a good idea to have on. So select somewhere here, and then zoom out, and then zoom in and select here. So we're going towards the middle. And then I know that that also needs to be 47, where this is where I would turn near off and just snap there. And there it is. So now both of these are at that 47, right? Of course, based on the chair type, that might look different. I'm gonna just slightly move this over until we organize these. So these two are scaled correctly. So let's move on to this other two. I'm going to slightly just move them over so we have more room. Okay, so these are scaled correctly. And let's proceed. So actually, it's telling me that top of the seat is 41.9. This is one of those cases that, because of the shape, maybe will be a good idea for me to have drawn that. So I'm going to zoom in and I'm going to just trace that top and I will just draw that as a guide. And then the second thing, I can also just draw up a line here. So what we're trying to do is just trying to create these references. So from there to there, correct? And so you see that I don't have the near snap on if I don't need it. Now, what I need to do is I need to scale that to be 41.9 centimeter. So select the image, again, type scale, enter. So we're saying whatever this is, so from this point to that point, what it needs to be is type again 41.9. There it is. So now that's also scaled. And I could, keep these or delete this. In this case, I'm going to delete. And in this case, this value is in inches. So I can have a similar approach. I can draw a line. This is basically top of the seat. And then I'm going to draw another line, enter from here to here, whatever that is, right? So that's supposed to be 17. So let's select the image, type scale. We're saying whatever that is from here to here, that actually needs to be. And although my drawing is, or my file is in centimeters, but I can overwrite that. So I can say 17 and then use the inches. There you go. So that's now 17. So we see that actually now all four of them are to the right scale. Great. So this is where, I can keep my references or I can delete them. I can certainly also keep them and just turn them off. So my images are on this layer. So I can just activate that and I can just turn off the guides. Here we go. So next thing we need to do is to begin to trace these outlines, and then that will become the lofting profile that we'll be using to then reference in Grasshopper and create our lofting. So the next thing we'll do is to create one master layer. So I can just rename one of these. I'm going to double click and we're going to call these curve profiles. And then under each of these, I'll create a sublayer and I'll call one eames, call the other one garden. And I'll create another one. I'll call that the Panton chair. Last one, I'll call that the zigzag chair. Okay, great. So this way I can just proceed with these one by one. Now, this is one of those cases where we could also lock the reference image, so then this way it wouldn't be moving. So I'm going to activate my eames layer and then lock the reference layer. So the goal here is to try to stay as close as possible and introduce some consistency. So for instance, I'm going to decide that I'm going to start to draw in this case, clockwise, and I'll follow the same profile along the way. So I'm going to activate the eames, and the best approach for us to draw this is to use a combination of an interpolated curve and polyline. So if you go over to our control points, or if you go to curve, go to freeform and use interpolate points, we will be able to draw this as accurate as possible. Now, we could use an approach where we use number of mirroring. Here, my concern is more about practicing drawing of curves with you and lofting rather than a perfect symmetrical shape. So my suggestion is for you to begin drawing using interpolated curve. Again, that was under curve, under freeform, and interpolate. So by default, it's going to be set up to 3 degrees. So we're going to keep it as is. So zoom into one of the corners and make sure that your ortho is off. And let's begin drawing. And try your best to match the edges of the image. And this is going to take some patience. And it will teach you along the way how the curves operate and control points. So where do we need maybe extra points for us to have certain curvatures that we want to achieve? So remember, we're working with NURBS curves. These are number of splines. And where is it that maybe we don't need as many points, right? So certainly when you want to rotate, or when you arrive to a sharp corner like this, having control points, it will help you to control the specific geometry more than others, right? So let's proceed. And this is where, if you make any mistakes, we can do Control Z, can try to play with this. Certainly, we don't need this to be absolutely accurate as long as we generally see the profile of the chair. So I'll do some higher maybe distances here. Let's try our best to match the profile. And here, I'm just interested in the profile of the chair. So as you can see, I'm zooming in, zooming out. And you can always Control Z. Let's see how this is starting to look. So this will teach you how to eventually create rebuilding. Where is it that we want to extend? Where is it that we can introduce adding a control point, subtracting, etc. So we're almost there with this one. It's a good practice for you. And I might need to, in this case, maybe do a straight piece and try my best to go a little bit further out so I have a sharp. There we go. Then I'll turn the corner and we're almost done here. So I think after this exercise, you should be quite comfortable with drawing these curves. And remember, all of this, we are using 3-degree curves, which is the default of what Rhino is facilitating with the geometry. And there we go. So you can see that here I have that awkward turning, and here we go, we can do that. So at any point after you're done, you can certainly turn on the control points and begin kind of manipulating it further, but I'm pretty happy overall. So that's done. I'm going to move on to the Serenan. So the same operation. So I'll start from this corner, and you want to have another interpolated curve, and certainly if you are using the icons, the second one would be the interpolated curve. I will begin from here, so it'll be a little bit easier. So with certain, there's larger kind of curves, so we should be able to do this with much less control points. So again, you're getting a good practice tracing. And here we need to do a sharper turn. And here we go. And as I showed you, after you're done, you can certainly go back and adjust the control points if needed. But if you could get away with fewer points, go for it. Now, in this case, I can either account for the cushion or not. So I didn't in that case. So I'm also going to avoid the cushion here. So that's going to be a rule that I follow. If you choose to kind of follow the cushion for the other one, then just stay consistent. Here the goal is to just learn about lofting operations. Here I go higher. Again, great exercise for learning about curves. And one more here. I'm going to do you can see that here I actually might need more anchor points in order to do a sharp turn here, right? So we move on to the pendulum chair. So I'm always starting from here and same operation. And so I might need to go back here so I can do this turn. And it's always about balancing the control points. And staying true to the shape. Okay, almost done. Okay, so this one I need to do a sharp turn, so I'll do that by introducing a few different control points there. Okay, and then the next one, of course, this one is angular, so it's a 1-degree curve. So I'm not going to be using the interpolated curve, but we'll use the polyline, right? So let's use the polyline, and I will be using, so in this case, the chair is flipped. We will need to do some adjustment, but let's just begin. Let's begin from this corner, and then we will flip this at the end. So certainly this is going to be quite easy to draw, and I can hold shift in this case. I can keep that line straight. And then again, shift, and then here, and here we go. Shift again to make that straight, and then again, and here we are. So this is one of those cases that there's a couple different ways we could do this. I can either extend it, we can also use a command called connect. Let's try that, connect, select one, select the other, and it actually closes it for you, right? So it becomes a great way for you to work. Okay, at this point, I can just proceed without the reference images. And the next thing we want to do is we want to align. So right now, if I go to our perspective view, you'll see that they are all placed on the ground plane, on the C plane. So let's select them, and I can either do this with the images or without the images. We might as well rotate the images. So we can select all of the images, and what I want to do is I want to rotate them up so then we can do lofting. So there's many different ways we can do this. Certainly we can use the gumball, and with gumball, the rotation axes are these quarter circle, and I can either here on the red enter a number, and you can see that it's going counterclockwise. I can enter 90 degrees here, and there it is. So because the reference images were locked, they didn't rotate. If I want to do this with images, I would just need to select everything and enter here 90 degrees. So that certainly works with everything. The other option would be if I do not want to use the gumball, I can rotate everything along the guide axes that we created. So if I turn on the guide, I can rotate everything along here, right? So let's go ahead and do that. So select everything, and there's here we can do a rotate 2D or 3D. If I do rotate 3D, that would allow me to rotate along an axis. So you can just hover over the icon and then do the right click. Or rotation is a type of transform. So if we go to rotate and do rotate 3D, it's asking for what is the start of the rotation axis. So in this case, it's ultimately this guide line that we have. So select one end, and you can either select the other or you can hold shift. And ultimately anywhere here you can lock. Then it's asking you what is the angle. And the way I could do this, I can hold shift again and either snap or drag my cursor on the ground plane. I can certainly snap to this image, right? Because we have midway and intersect on. And then here it allows me to rotate. In this case, I can then enter 90 degrees, and here we are. So now everything is rotated. So again, we can use the gumball or we can use rotate 3D. Okay, wonderful. The next thing we want to do, and I'll at this point go ahead and turn off the guides again. I want these to be aligned in a way that I can then loft them side by side. So I will select each one. And again, I can either rotate along these axes, or in this case, I can rotate each of them using the gumball. So you see the blue here, it would allow me to rotate along the X. So I'm gonna left click on the blue. And if I wanna rotate back, so then in this case, if I pay attention to the arrows, then I would need to rotate them negative 90 degrees. There it is. Same with this. So I'm right now selecting the image and the curve together, and left click again, and I want to do negative 90. Likewise here, we do negative 90. And in this case, we have to do it the other way. So we're going to do 90, right? So now these are ultimately set up as profiles. So at this point, if I turn off the reference images, you should see that they're starting to look like profiles that I can begin to loft together, right? So if I look at this from top view, they're a little bit scattered, but that is going to be part of the kind of the fun of lofting these together. So now if you keep in mind the way I drew these, each of them have very different number of control points because of course the shapes were very different. So through this exercise, we will learn about different properties of lofting. In this case, we're dealing with 4 different curves with very different number of control points. So for me to proceed, first thing, I'm going to turn off the grid. So F7 turns off the grid, and let's just assume this is the shape that we want to go with. So let's go ahead and in command line called Grasshopper. And first thing I want to do is to reference these these chairs. Now, I can either reference these individually or I can reference them collectively, like all in one go. For the sake of keeping this clean and repeating the operation, my recommendation is that each of these are referenced separately so we can swap them and change their position. So if you recall from the previous exercise, in our Grasshopper window, which is ultimately a floating window that allows us to do visual algorithmic editing, we have a number of different geometry types that we could use to reference geometry from Rhino or pass on through the definitions that we're constructing. So definition is a Grasshopper algorithm that we're compiling using various components. So under parameters, this is where we have our different data types, and geometry is a data type. And within here, we have different types of geometry, and I can either use a specific container, and these are geometry containers that, for instance, only takes curves, or I can take a generic container such as this, which is just taking any type of geometry. My preference, especially when you first begin with Grasshopper, is to make it as specific as possible. So then if you are making a mistake with the geometry type, then it will give you an error and you could fix it, right? Rather than just using a generic container. So again, under parameters, geometry, let's grab a curve container. And the way we grab the container, you just drag and drop. And in the beginning, a container like this is orange, and orange always means that it is missing information or is waiting for information. It has this bubble that it tells you that the object contains one warning, which is floating parameter curve failed to collect data, which we have is because we have not still referenced anything. So you will do this 4 times because we have 4 different chairs. So we can either go to parameter, geometry, and grab a curve container, or we can double click on canvas, type curve. Now, when you do that, you do get quite a few different types of curves. The icon that we're looking for is this curve container. Now, it might be that your preview is different. So if you go to your Grasshopper window under display, there's a few different options. One is to draw the icon, which I prefer because then we can match icons with icons. And the second one is draw full names. And what I like about draw full names, in this case, there's nothing to preview yet, but it actually will show us what different elements are called. So I am going to select these and both of these and do Control-C, Control-V. So then this way we have 4 empty containers. And when you have these containers, as long as it's more than 1, or in this case 4, I can align them, right? And we can even do different spacing. And we just need to use annotation in order for us to keep track of what is what. So if I were to look at the top view, of course, we have these kind of left to right, and this is top to bottom, but hey, as long as we're keeping this consistent. So I'll start with the Eames chair. So go to the empty container, right click, and select set one curve, and that minimizes the window. And now you could select a curve that's drawn in Grasshopper, and then the color of the component changes. The color changes because now it has what it needs. It has data. And once you select it, now that is being highlighted. So this is a preview in Grasshopper that we have. Although this curve already exists in Rhino, and that's what I'm referencing, but I wanted to show you something. If I turn off, in this case, the Eames profile, right? You could see that there is still a highlight here. So basically, not only I have the Rhino curve, but I also have the Grasshopper curve, right? So I'll do this one by one. I'll turn them off for now. So let's continue, and we're going to reference the Sarnan one. And actually, before anything, I'm going to select this container in Grasshopper, select it, and press Control G. And what that does, it groups itself or groups it to itself, but it actually gives you this boundary that if you right click, you can then name that group, and we're going to call that aims. Then let's proceed. The second one, right click again to set one curve. And I will do the same thing, which is turning off the preview of the curve, right? So now that is red. So red is the default color of any geometry that's in Grasshopper. So how do we set that up? This is actually this icon here. It says document preview settings, which shows that any geometry is red except for when it's selected. So in this case, when I select, they will become red. I can certainly change that color if you're colorblind or if you don't like that color. So when selected, they are green. So then I'm going to select this, group it to itself, and we're going to call this Sarnan. Then we go forward. So right click on this again, set one curve, and I will turn it off and select and Control G. And we're going to call that Phantom Chair. Last one, we select again, set one curve, and I will turn off the zigzag chair. Here in Rhino, Control G, and this is the zigzag. Great. So these are contained here, and if I look at what each of them say, and remember last time we used this thing called a panel, which is, I think about it like a sticky notes under parameters, input panel. You can drag and drop, and you could see what is kind of contained within each container, right? And this says it's a reference periodic planar curve, right? That's what it is. You can also pull up this panel by double-clicking on canvas using a quotation mark, enter, and that gives you ultimately a panel as well. So in this case, it's not giving me anything more than this is reference. But if I were to right-click on any of these and go to this option called Manage Curve Collection, and if I click on what it is, and you'll see that this is where we actually see that geometry ID that we've been talking about. So that's what it's containing. So that's how it knows that it's kind of tied back to that specific instance of geometry in this specific instance of Rhino. Okay, so each of these, we will be seeing the same thing. So I can use panels in this case to read one or many different information. So I don't necessarily need these panels right now, so I can delete them. Sometimes you use them to kind of verify information, and then you could proceed. Okay, so the next step for us is to create a lofting between these curves. So let's go to our surface tab, and under freeform, this is where we have this loft component, and it's asking for curves. So it's asking for more than one. So let's try to see how we will do this, because each of these contain one. So when you are trying to compile, in this case, these are each individual different curves. When I'm trying to compile, there's three different ways we could do this. I can either feed the wire as an input to curve, and you could see that it's actually throwing in an error because it says loft could not be constructed, right? Because it only has one curve. However, if I hold down Shift, and if I drag the second curve, you'll see that it is actually understanding that there's more than one. So it is giving us the loft. So if I continue to hold down Shift and drag and connect, and the next one, you'll see that actually it is working. The only thing is that it looks like the way that this curve is constructed. So there is basically the surface is starting to twist. But up until that point, so if I'm going to disconnect this, you can either right click, go to disconnect, and then highlight each of the wires, right? Or you can hold down Control and then just drag the wire back, trace it back, and you'll see that. So that definitely works. And so far, we're not doing that bad. But sometimes if you have too many wires, it becomes a little bit tricky. So one thing I prefer is to use a component called merge that allows you to actually very easily add and subtract different components. So we'll find the merge component under sets, under I believe it's here. I always need to, here we go, under sets, under tree merge. And this component, all it does, it allows you to just connect different things. And it could be a single thing or a multiple thing. So basically, before I connect things to Loft, we're going to merge. So I can right click here and go to disconnect and say disconnect all, and then start one by one. And the way this works is as soon as you provide more than basically it has the same enough kind of wires, then it gives you an additional one because you understand that there's more to come. And what this does, it creates a new list. So each of these are individual curves. Now it creates a list or a container with 4 things. So I can always double check by double clicking on canvas and creating a new panel. And you'll see that now it is reading these 4 different curves. There, 3 of them are similar because we use interpolated curve to create these. However, this one, we use the polyline, right? So that's ultimately what we're looking at. Now, instead of holding down Control or Shift, if I just drag the output of this to input of that, there it is. So again, this is similar to what we did before. It kind of works. Now, our next step is to just refine this in a way that we can actually fine-tune the surface a little bit better, right? So here it's twisting. Now, the reason for twisting is that when we constructed this, I used a different number of control points. If you remember, I'm going to turn on the curves. And if I select these and turn on the control point, which is beyond or points on, this has very, let's say, fewer points than these, right? So when we are lofting, these things allow your geometry to behave one way or the other. But we have this thing called loft option, which sometimes it allows us to override things. So I'm going to escape and I'm going to turn off these profiles again. And actually, at this point, I'm going to go back to our default and I'll turn off the curves. So let's see what these lofting options are. And we'll find the lofting option component underneath our surface component under freeform, right where we found loft, right next to it, we can find loft options, which is right here. So ultimately, loft options, it allows us to extract what is already happening here. So if I right click on options, it gives you the option to, for instance, change the type of your lofting from normal to loose and others. It also allows you to do, for instance, close or align sections. But if I use a component like this, I have actually more options, such as rebuilding the curves with a specific or the same number of control points. So let's start off by first just connecting these. And let's go through them one by one and see what it is that we want to adjust. So the first option is whether I want to close the loft. And this is not a good idea, but let's try to see what it's going to do. So basically here it starts from item 0. It goes to item 1, 2, 3. So it lofts from this to this to this to this. But if I were to close it, it would try to connect from this last element to this first element. And that's not going to work, but let's see what that looks like. So this is a toggle. It's either true or false. It's asking, do you want to close this? And Boolean toggles are type of parameter inputs, which we find them on the parameters input Boolean toggle. And by default, this is set to false, which is what this is. But if I double click, you'll see that it's trying to do these basically kind of looping back there, right? So certainly I don't want to do that. Okay, so the next thing is adjusting. It's adjusting the seam. So what is the seam? So I'm gonna close my Grasshopper by Xing out of it, and I'm gonna turn on the curves to explain what seams are. So if you remember in an earlier example, we were looking at the seams of the surface, or for instance, in the case of the sphere. But let's take a look at this. If I select this, and if I run this command called direction, which we can do that by going to analyze direction, you'll see that there's this start point and an end point, right? So it basically starts from there and ends from there. And if you recall, that's how I started to draw this, right? So let's check the seam for these other ones, and I can do them multiple ones at once. dir, enter. So you can see that this one is going this way and the other one is going the other way. So it looks like these are all going in the same direction versus this one is going to the opposite way, right? So that has to do with the way that it's drawn. So what that means is that although I tried my best to make the seam in the same position, but maybe the direction is off. So let's see if this is something we can fix. So I'm going to go ahead and call Grasshopper again. And we will here go back and make a copy of this Boolean toggle. So Control C, Control V. And let's see what happens if I connect to this and do adjust. So it looks like actually it made it worse because now it's trying to adjust to this. Okay, so I'm going to actually undo that. If you recall, like when we were working here, when I was looking at the direction, it looked like actually the curve was going the other way. So let me just see what happens if I flip this and then enter. So it looks like it kind of worked for certain things, but again, the number of control points are off. So I'm going to actually undo that, right? So the next thing, let's see if we can fix it by rebuilding. So if we don't rebuild, it's going to keep the control points as is. So meaning this one has, for instance, if I run the command rebuild, this one has 10 control points, sorry, 36 control points, versus this one has 12 control points, right? So they're quite different versus this one has 50, right? So it's 50, 36, 12, so that's quite a difference. So let's try to create a slider. So similar to what we did earlier, going to make a slider. We're going to double click and we're going to make a slider that goes from, let's say 10, less than 30, less than 50. And this number is just based on the average that I just saw. Enter. And let's try to connect this to rebuild. And you'll see that actually it's starting to become smoother, but definitely it's losing its quality, right? So higher this number is, better it's becoming. Okay. Then the next element is refit. It says refit the tolerance. So this is also a Boolean, this is also a number value. So I'm going to make a new slider that goes from 0.1 less than 10 less than 20, enter. And let's just see if it makes an impact, but in this case, actually it doesn't, right? So it looks like the most drastic one is rebuild. Now, keep in mind, if I disconnect my rebuild, actually the shape will be closer to what it was, right? Because actually I'm telling it don't rebuild. So let's keep this here and I'm going to disconnect this. So later on, we'll try all the options and see what is possible. But the last one that actually has a lot of impact on the shape is the type of lofting that we can do. So in this case, by default, it's set up to be 0, which is normal lofting. This is what we tried earlier with the example. Then we have loose loft, tight, straight, and also uniform. So it means that if I change the number here, if I right click and select any of these options, right, you could see that actually the format is changing. So these numbers, 0 through 5, so if I make a slider 0, less than 1, less than 5, will allow us to go through different types of lofting. Of course, that's a bit drastic, right? So maybe we could still stay with 0 lofting, which is normal. And you could see that now. These are the options. At this point, there's a couple of different things we could do. One is we want to slightly play with the placement of this and see if there's a better combination. And this is something that I encourage you to do. So if we go back to the original setup, so remember the way these are set up, basically we're connecting them one after another. So let's see what happens if I'm just connecting this first 3. So I'm going to disconnect this fourth one, which we could do by either holding control and hovering over the input or the output, and then trace the wire back. Or if I control Z, if you right click on the input, go to disconnect, you can also disconnect it from here. So let's try to analyze these 3 shapes. And so it looks like generally they're it's lofting, but then some of this areas is a little bit kind of rotating because of course, again, they have different control points, right? So let's see if we come back to any of these options here. So I'm going to do adjust seam yes. So when we do that, so it looks like this first 2 are building well, lofting well, but then afterwards it's not doing that. And then let's try to use the rebuild option, which in this case, if I increase the control point, so it looks like it's generally working. So let's try a couple of different options here. So I think this is quite interesting, but I'm wondering if we can make some adjustments just between these 3 and then work on the rest. So we mentioned that if we use the command dir, this is where you're starting to see this thing called a seam, right? And we could drag the seam and slightly adjust it, but there's a better command for that. So there's a command called curve seam, CRV seam. And ultimately, this is working with closed curves, which is what we currently have here. So when you're done selecting, right click and enter, and you can see that now instead of direction, which only basically gives us all the option, this one, it allows us to basically drag a seam and see what happens if we do that. So it looks like for this back here, actually it is making it worse. So these operations that I'm showing you, they don't necessarily need to work for this specific option or setup, but these are things that we can do regardless. So I'm going to try one other option. I'm going to try to do adjust seam yes, because that really lofts these 2 really well. And if I move these over, you could see that they're generally working well. I think that's a nice bench if we were to just look at those 2. So I'm going to try to see if I could slightly adjust the seam for this, and then we'll do the same for this. So let's select this and do curve seam. And I'm going to, in this case, actually, as you could see, it goes from here to back there. So I'm going to slightly push the seam higher, and let's see if that makes an impact. So it improved it a little bit. And then let's try to do the same thing here. So from there, it actually comes all the way here. So I'm going to select this and see, can I flip this, right? So it looks like flipping is also not working. So let's do curve seam again. And so in this case, we have quite a lot of maybe adjustment to do, and I'm going to push the seam back here. Okay, so it's starting to fix from there to there. Let's try one more time. And I will push the seam. Now let's try pushing the seam here. From there to there, right? So one more time per seam. So we want that to switch to that size from there. What if it becomes here? So I'm gonna unchecked adjust seam. And starting to work from there to there. And part of that is also the distance and the way that it's positioned. So if I'm moving that back, you could see that actually from back there to back here, it's starting to loft, right? So that's working. So you want to spend some time and just playing around with the positioning, with adjusting. I think now these two work well. So there is no specific formula you should follow. You should just start to adjust them until you like the form. And sometimes actually having a twisted form is interesting. And this is going to be generally the struggle for this type of geometry. So I'm going to adjust that here. I'm going to actually push it up one more time, curve seam. And let's select that. And I'm going to adjust that to be there. Okay. So I'll try this one more time. And so basically from here, it's shifting over there, right? And then I am gonna see if I move it back. So it's giving us that kind of curve option there, right? So not back. Okay, so let's try to also position this last element. So if you recall, basically this curve is already connected, right? So from top, that looks interesting. The problem is probably if I connect it right now as is, it's going to twist, but it looks like it's not too bad, right? So it is quite interesting. I'm gonna look at them from side. So they're all definitely on the same plane, but you could see that how the profiles are changing. So I could see this bench working as a fabrication piece. Maybe I want to move this a little bit closer, right? Maybe a little bit further back, but definitely you're starting to kind of look into how these might be coming together. So I'm going to press F7. It looks like this has slightly moved and that might happen. So if I look at the front, yeah, definitely. And this could be one of those cases where we use a command call set point. So what we'll do is we're going to move this down and we're going to set a point. And I'm going to select this and I'm going to use an option here called Smart Track, and we're going to type move, enter. And earlier, if you recall, we had a guide here, right? So we can use that for snapping. So select one of these control points, and then you could snap to one of these, and there you have it. So now we're able to actually make this a little bit better. I can even push this forward a little bit more. And that's a way for us to get the chair more integrated. Great. So far we have this, and I can turn off the guides, and I can turn off the profiles. I'm gonna go back to Rhino Grasshopper, and let's take what we have, and this is the lofted surface. And I'm gonna delete this slider. We can just work with what we currently have. And let's group these together. Control G, and we're gonna call this lofted chair. And here I'm gonna group this together and say this is our merged curves. And you can delete this. So next step for us, we're going to contour this and turn this into basically more of a fabricated piece. So one of the ways that we can introduce contouring is by ultimately slicing this piece. So imagine this could be perhaps made out of plywood. So we're going to go to our intersect tab under mathematics. We have a component called contour. And with contouring, we need to provide a direction for contouring. So we're going to connect the loft as the shape input. And we will use the ground plane 0, 0, 0 as the start of the contouring and the direction of contouring. In this case, let's just say we want to contour it in X direction, right? So this way. So these could be plywood ribs, for instance. So we're going to go ahead and under vector subtab, select a unit X vector. That will be the direction and the distance. So if you recall, we're working in centimeters, and for distance of contouring, we're going to create a 3 centimeter perhaps profile. So I'm going to create a slider that goes from 1 less than 3 less than 10. And let's go ahead and connect that. And this might take a few seconds. And you'll see that now we have this ribbed structure that's created. So these are basically the contours that are slicing the geometry, right? So it looks like a really nice geometry. We can certainly increase this distance and then extrude them accordingly. So in order for us to do this, as you probably saw, it took a few seconds for it to be processed. So this is one of those cases that you do not want to drag this number, right? So we can just double click on the slider and just enter a larger number such as 6 and just allow for it to process. There we go. And if I were to turn off the lofted option, select, right click and preview off, now you have this beautiful lofted structure. Now, don't worry about the shape. Yours could be slightly different. Remember, you're basically playing with the positioning of the curves. You're also playing with the seam. So this is completely up to you how you would like it to be shaped, and just do it as you see fit. The next thing we want to do is we want to extrude these. So then they look like actually plywood ribs, right? So for us to extrude these curves, we're going to go ahead and go to our surface tab. We're going to go to our freeform tab, and you'll see that there's 4 different ways that we can extrude this. So there's extrude along a vector, extrude linear, extrude to a point, and extrude along. And in this case, we're going to use extrude based on direction of a vector, since we already have this x direction vector that we're using, right? So that's how we're contouring this. So I need to provide a vector and then a mount that we are extruding. So I'm actually going to make a copy of our x vector. And for the amount, basically, we need to provide an amount. I'm going to take whatever this distance is and divide it by 2, right? So this way we can create a plywood, let's say, structure that looks like it's spaced every other. So for us to do any operations, we're going to go to maths, we're going to go to operators, and we're going to use a division. So we're going to say whatever that number is divided by 2. So here I can either enter another slider, or if I'm certain that I always want that to be 2, so then it looks like it has even spacing and same distance as the material, I'm going to double click. I'm going to use quotation mark to call a panel, but I can also enter the number already, so divided by 2. So that's how we are creating that panel. So that becomes the amount. And the reason why I'm setting this up before I connect to this is because this might be a heavy operation for your computer. So you do want to make sure that you have the vector connected, and then you go ahead and connect the curve. So what you will see is that there might be some discrepancies, and that so usually these should be extruding properly, but you'll see that actually they're open curves, right? Because we're ultimately extruding the base. So we could do 2 different operations. We can either cap this geometry after we extrude them, or we could actually create planar surfaces and then we extrude them. So let's try that approach. So I'm going to go ahead and disconnect this first. And we're going to go back to our surface tab first. Under freeform, we will select a component called boundary surf. So this is a boundary surface or a planar surface. So let's take our contours and connect it to here. And you'll see that what it will do, it would actually take these profiles and it will extrude them. So here we're looking at some of the double. So let's go ahead and turn it off. So then it is not very confusing. So these are the original curves. So I can select them, use your middle mouse button and turn them off, as well as the curves here. So select middle mouse button and turn them off. So here what we have is these ribs. And then we're going to go ahead and connect that to the base. And then this is where we have our extrusion, right? Where these look like these solids. Now, of course, we would need to develop more details. And then this relationship is also parametric. So if I change that to 5, and again, I'm not dragging this, we will have ultimately much smaller spacing, and this could be all based on the material. Great. So last thing, we're going to apply a color to this. So then you're able to render this with some more, I think, definition. So first, let's go ahead and group these together. So then we have our contour components in one place. We're going to connect these and say these are contouring the surface. And we will take the exports or the outcomes, and then we will go to our display tab. Under preview, we will look for a component called custom preview, which is what we've used before in the previous definition. Connect the outcome here. You'll see that actually the way it renders it It's much more pleasant than the preview that Grasshopper has, right? So we can go ahead and turn off all the previous previews. And then let's go ahead and change the material quality here. And I'll go ahead and go to parameters under input. I'm going to look for a color swatch. And with the color swatch, you can right click, you can add more definition to it, as well as we can turn this into a material. So we can go to our display tab under preview and create a material. And with materials, we have more properties. So for instance, for the diffuse color, if I just attach it as is, and then connect it to material, you'll see that it actually has a darker tone. The reason for that is that it already has an emission color, a specular color, and a shininess. And all of that kind of drastically impacts the way that your material is starting to read. So let's try to make this more maybe within, and then I could use the same color swatch, and then we could work with the specular. So specular is the color of your material when you're shining light on it. The emission, it has a drastic impact. So by default, the emission color is black, but if you change that, it's going to change the way that your material is being reflected, right? So this is definitely something we can play with. We also have transparency and shininess. So transparency is a value between 0 and 1, so we can use a standard slider. Something like that. And then shininess, it's a 0, 100, 0, 1, and 100. Around 50 something, it works well. I'm going to make a slider around 50. Now, keep in mind that the properties such as shininess, it will not be that visible inside this preview unless we bake the color and then do another rendering, which is something we'll do in our future iterations of this. So by switching to the render view, you'll see that actually this is starting to look like an interesting development. So just remember that everything we have ultimately comes from these 4 curves. Now, if I were to move any of these, you'll see that it will take a while for them to update. So for your assignment, when you arrive to this point, I ask you to save 2 different iterations. And this is something that you might want to take some time doing. So definitely we want to go ahead and save our definition as is. So I'm going to go ahead and save my Rhino file, and I'll save this. I'm going to call this M1.2 Rhino. And go ahead and file and save this as M1.2 Grasshopper. And this way, if you come across any issues, you definitely have a backup. So what I want you to do at this point, go ahead and in Rhino, let's make either 2 new layers or use the layers that you're not currently using. And you can always tell if you're using a layer is if you right click and do select objects, and if it's empty, then you're not using these layers. Or you can always try by running a purge. So the purge will get rid of layers that are empty, right? So for sure, then I'm not using that. Now, I do still need a new layer, but purge is a good operation to run. So I'm going to call this bench version 1. And I'll make another layer, which we're going to call it bench version 2. And let's activate version 1 and go back to our Grasshopper definition, and we're going to go ahead and bake the geometry. So remember, baking the geometry allows us to take the geometry from the Grasshopper preview into Rhino. So I can either bake the geometry here or bake the geometry here, because this is an output and all we're doing here is providing an input. If you're ever not sure for your future versions, you want to set it up in a way that you can certainly know what to bake. Here we can go to parameters, under geometry, grab a geometry container. And here we could ultimately store the geometry here and then feed it here. Now, this is an extra step indeed, but what I like about this is that we can then write a note. You can say bake me, and or bake this where you like this. And next time when you open this, you know that this is the way to go. So whatever version you currently have, go ahead and right click, go to bake, and then save it inside bench version 1. So this is one of the ones that you'll be submitting. Make sure that you group and then press OK. So it will take a few minutes. And then if you now close this, you'll see that, yep, that is already there. So once you bake that version, we're gonna now bake another version. So hide that layer. So when you're submitting, I still see this. So now let's go ahead and go back to Grasshopper, and we're gonna make some adjustment to the form. So then this way you'll see how the operation is proceeding. So let's go ahead and we could see how we proceed. So we are going to select our curves. So for instance, what I want to do is I want to take this profile and I'm going to move it forward. So let's see how the curve adjusts based on that. So if you start to see that it's taking a while for your computer to process, or we're starting to see this operation, it means that I actually need to make some changes. So what we could do is we can come back to Rhino Grasshopper and we could kind of separate, right, this process from this process, because this is actually what is taking a while for it to process. So to do that, you can hold Control or you can right click on the input and disconnect. And what disconnecting does, it allows you to just temporarily cut that component, and then you're able to then, move forward. So for instance, I tried this and it looks like it's flipping. So I can either adjust the seam again. So we do curve seam. And right now the seam is there. So I want to bring the seam, let's say here. Something like that, right? So we were able to fix the seam. You can adjust it further. And then let's say I want to also bring it more forward. So I'm able to do that. Maybe a little bit more. Let's say that works. And then this one, I actually want to maybe move it back, something like that. So whatever that might be. And maybe I want to do some seam adjusting here. So I do curve seam. And I will move this forward here. Something like that. Right, so it looks like I need to work on this a little bit more. With this one, it twists and it goes there. So from there, that goes all the way there, right? So let me try actually moving it back there. So it looks like it's not impacting that much. It might just be that trying that. Okay. The other thing we could try is swapping the order, and this is if you want to try something different. So you see like here, we're going in this order, but let's see what happens if I move these, right? So this is the zigzag. So I can just swap. So I can connect this one to number 3 and this one to here, and then I can disconnect this by right-clicking and disconnecting. And then what I need to do is to just swap the order, right? Because right now that's going there, and then this is coming over here. So it looks like right now it's twisting, but it's not too bad when it gets to this point. So this is one of those cases that again, we're trying to really understand how curves work, directionality, seams. So let's try seam, adjusting the seam here. So that goes there. So that's not too bad. It's just it's flipping over there. So I'm going to drag this down here and see if that works. So that goes up here, that goes up there. Let me try flipping the direction. And I will undo and then redo that. So yeah, it looks like that one is definitely. So let's try adjusting the seam here. So I'll be moving this down here. Okay, from there to there. Looks like that's a big stretch. Okay, something like that. It's not too bad. And then just some flipping here that it needs to be fixed. So I'm gonna change my view to here and I will do curve seam again. And let's see, so it looks like that's right now going all the way over there. And I will be trying here, right? Not too much, one more time. A bit better. So, time. Yeah, this part is not adjusting well. I mean, keep in mind that these are very extreme seats, right? So we're trying to basically explore lofting, and now it's flipping here. So let's see, this is completely twisting. So what if we don't adjust seam? I will see. I'm gonna select these and do direction. So that one basically is going this way. They're all going up, going down. So this one needs to change. Yeah, so all of them, they need the adjusting. This one. There we go. So that was it. So by flipping that, we were able to fix that, right? So just try to find something that looks like it could be possibly executed. And the goal for this is to not fabricate this, but kind of play back and forth, rebuild, etc., and just see how your what the properties are. And I think it's an exciting exercise. And once you kind of like the surface, just select this loft and connect it back to shape. It will take a minute for it to process, and then it will give you this parametric design, right? So yeah, certainly that's something we want to think about, and that's the general surface. And once you like the design, I will go ahead and bake this one more time, right click, and then let's go ahead and bake, and let's save that on version 2, right? So now we have two different versions. If I were to close this, we have version 1 and version 2. So if I were to hide the curve profiles, just look at these one at a time. So that's version 1 and that's version 2. So I want you to just do this exercise and then select these two options, right? So you can see that once you have the logic, then it's quite easily you can select these options. So this is the instruction, and I'm asking you to ultimately create two different lofts, and then please go ahead and save your files with your last name underscore M1.2.gh and the same thing. So before you submit, just rename your files so then I'm able to find them. Thank you so much.